Hi everyone, this is Nilab again. In this video, I'll be talking about redox reaction and acid and bases as well. So before we get into the topic, we need to define what do we mean exactly by acid and base and also their reactions. So acids are the substances that dissolve in water to produce hydrogen ions, whereas bases are defined as substances that dissolve in water to produce hydroxide ions. Acids are proton donors and bases are proton acceptors. Also, the pH range for acid is between 0 to 7, and the pH range for base is 7 to 14. For example, here we have two reactions. For the first one, we have hydrogen chloride, which is an areneous acid. When we dissolve this in water, it will produce hydrogen ions and chlorine ions. In the other hand, we have sodium hydroxide. When the sodium hydroxide dissolves in water, which is an areneous base, it will produce sodium and hydroxide ions. So in this case, we know that the first reaction is acidic reaction and the second one is a basic reaction. What do we exactly mean by redox reaction? So redox reaction is a chemical reaction that involves a transfer of electrons between two elements in a reaction. So these reactions are composed of two different half reactions, which are reduced half reaction that gains the electrons and oxidized half reaction which loses the electrons. There are two elements in the reaction that exchange electron between them. One is the oxidizing agent. This is the molecule that accepts electron, so it gains electron. And the other one is reducing agent. This molecule donates electron, which loses the electron. So for example, here we have zinc and hydrogen. So they react together and they will produce zinc ions and hydrogen. So in this case, hydrogen changes from +1 to 0. The charge will change from +1 to 0. So in this case, we can say that hydrogen is reduced, like the charge is reduced from 1 to 0, and hydrogen is an oxidizing agent. On the other hand, zinc changes from 0 to +2. So the charge in zinc increases. So we can say that it is oxidized and it acts as reducing agent. In this slide, we are going to balance a chemical reaction into an acidic reaction. So for balancing a chemical reaction into an acidic reaction, we need to apply these 4 points to the reaction. The first one is balancing the main reactant and the product. So we need to look at the products and the reactant first and check that they have the same the number of molecules in the both sides of the reaction. The other one is balancing the oxygen. In this case, we're just simply adding water to any side that we need oxygen in it. And then the third one is we need to balance the hydrogen. So for balancing hydrogen, we're just gonna simply add hydrogen to any of the side as same as oxygen, balancing oxygen. And also for balancing electrons, we're gonna do this at the very last part of balancing the reaction because we need to check all the protons and everything, and then we can balance the electrons. So for example, we have a reaction here, which is a zinc and nitrate. When they react together, they will produce zinc ions and ammonium ions. As we said in the first part of the video, that a redox reaction is composed of two half reactions, which is the reduced half reaction and the oxidized half reaction. So we're gonna divide this reaction into two half reactions, which is zinc and then nitrate to ammonium. In this case, we're gonna apply all these 4 points on these two reactions to balance it both, and then we're gonna add them together at the last part to make one reaction. Okay, so for the first one, we do not balance anything because they have the same number of molecules in both sides, in the reactant and the product side. But the second one is balancing the oxygen. So we just need to balance the oxygen in the nitrate half reaction, because it has oxygen, but the zinc doesn't have any oxygen, so it will stay the same. For balancing the oxygen and the nitrate half reaction, we're just gonna add 3 molecules of water to the product side, and then we have 3 oxygen on the reactant side. So the oxygen is balanced now, and zinc will stay the same because it doesn't have any oxygen in it to balance. The next one is balancing the hydrogen. When we added water to the reactant side, we have more hydrogen on that side, so we need to add hydrogen in the reactant side now. We have 6 plus 4 is 10, so we have 10 hydrogen in the product side. We need to add 10 hydrogen to the reactant side with the nitrate so that the hydrogens are balanced. And then zinc will stay the same because it doesn't have any hydrogen in it. And the last part is balancing the electrons. So we have plus a charge on the reactant side, on the product side, and then we have a minus charge and plus 10 charge on the reactant side. So we're just gonna add 8 electrons to the reactant side to balance the charge on both sides. And then for the zinc, we also need to change the balance the electrons. So we're just gonna add 2 electrons on the product side to balance it, because in the reactant side the zinc doesn't have any charge. So we're just gonna cancel out in the reactant side. It doesn't have any charge, so we add electron on the product side to cancel out the charges. And okay, this is done for the 4 steps. The last one, that we need to find our acidic reaction. So what is it? The product will be the combination of both these reactions. So we're going to add these 2 reactions together, but we need to cancel out all the electrons because we do not need the electrons for our acidic reaction to be in the reaction. So what we're going to do is we need to make the reactions, the electrons in both of the reactions the same. So in the first reaction we have 8 electrons, but in the second one we only have 2 electrons. So what we're going to do is we're going to multiply 4 electrons to the second half reaction, which will make the electrons the same, and then we can easily cancel them out. And this is the reaction that we have, 4 zinc, 10 hydrogen, and then nitrate in the reactant side. And then on the product side, we have 4 zinc, ammonium ion, and then water, 3 waters. Okay, so for the next slide, okay, so after balancing an acidic reaction, we can balance this reaction by taking one extra step to a basic reaction, which is just by removing hydrogen from that acidic reaction. So what we're going to do is, as we have 10 hydrogen in the first reaction here, we're going to add hydrogen on the other reaction in the product side to cancel out these 2 hydrogens. So in this case, we can only do this by breaking down the hydrogen. Water. So we have 10 molecules of water here. When we break it down, we're going to have 10 hydrogen and 10 hydroxide ions. So in this case, the hydrogen in the first reaction, which is acidic reaction, the 10 hydrogens will cancel out with the 10 hydrogen in the product side of the second reaction. So we don't have any hydrogen left for our final reaction. So we're gonna have 4 zinc, 7 water, because we have 3 water in the first reaction. So the 3 and 10 water in the second one. So we just cancel out those waters. We're just going to be left with 7 water, and then we have nitrate. And then on the product side, we have 4 zinc ions, ammonium ions, and then 10 hydroxide ions. So in a reaction, whenever we see that the reaction produced hydroxide ions, we say that this is a basic reaction. So in this case, we have 10 hydroxide ions at the end of the last reaction, so we can just say that this is a basic reaction. So that's it for today's video. Thank you for watching. Have a nice day. Bye.